Taking a look at another graph here, we have y equals negative 1/2 times 5 to the x minus 2 power. Interesting things happen when my exponent is 0, because that's where you're going to see the curve of the exponent. So if I take a look at here, my exponent is x minus 2. What value of x is going to have that be 0? Hopefully you see that. That's going to be 2 then, because x minus 2 equals 0, so x equals 2. So when I make my table, my curve is going to happen at 2. So what I'm going to do is I'll do x in negative 1/2 times 5 to the x minus 2 power. So I'm going to put 2 in the middle of my table. So I'll go 2, 3, 4, I'll go 1 and 0. I'm going to start with my middle when x is 2. So 2 minus 2 is 0. Anything to the 0 power is 1. So our answer is negative 1/2. Notice we have this negative up front. So what's going to happen is going to flip our graph. We're going to flip over the x-axis. Let's do it when we do 3 then. 3 minus 2 is 1. So 5 to the first power is 5 times negative 1/2 would be negative 2.5. Let's do it when x is 4. 4 minus 2 is 2. 5 squared is 25. Half of 25 is 12.5, so let's say negative 12.5. Let's go back and do x is 1. When x is 1, 1 minus 2 is negative 1. So 5 to the negative 1 power was 1/5. So we get negative 1/10, which I'll write as negative 0.1. Let's do 0. So 0 minus 2 is negative 2. So 5 to the negative 2 power is 1/25. So negative 1/2 times 1/25 is negative 1/50. And then I think I'll use my calculator here to find where that is a decimal. That's pretty small, isn't it? So if I take 1 divided by 50, I get negative 0.02. Let's sketch our graph right over here. So when x is 0, I'm going to be at negative 1/50. I'm going to be really close to the x-axis, in other words. Okay? When x is 1, I'm going to be at, whoa, what happened there? Oh, I got the thing at negative 0.1. So once again, not that much further down am I. When x is 2, I'm going to be at negative 1/2. So here's 1. So negative 1/2 I'll put right there. When x is 3, I'm going to be at negative 2.5. So there's 1, 2.5. When x is 4, I'm going to be at negative 12.5, which is going to be way down here in my graph then, isn't it? So then I could look at my graph like that. And obviously you can use technology, and I've done that already. So here's our graph. Look at your domain. Because of our transformations, our domain is still all real numbers. Okay, you can put any number for x you want, but notice y is less than 0 this time for your range. So our domain is going to be all real numbers. Make that a little bit thicker for you. It's here, because we blew that up. So all real numbers. Our range is going to be, y is going to be less than 0. Notice our graph got shifted 2 to the right. And so when our y-intercept was really small here at negative 0.02. Now when we look at exponential growth, this is just a different way of writing it. We have a times 1 plus r to the t power. It's the reason it's 1 plus r because you're growing. Because remember when we said we were doing growth here, this never had to be bigger than 1. So r is going to be our growth rate, t is time, and a is our initial amount.